This is Pre-Calculus A, Unit 7, Lesson 4, Finite Arithmetic Series. So we've gone from talking about sequences to talking about series. And it's really easy to get the two terms mixed up, but there is a very important distinction between the two. Okay? Here is a sequence. Think of sequence as order, right? Sequence. So 5, 11, 14, 17, let's see, 5, actually, let's, 5, 8, 11, there we go, 14, 17, 20. Okay, notice each term is separated by a comma. You recognize this probably as an arithmetic sequence in which the common difference is 3, provided I did the arithmetic correctly. All right, and the first term is 5. A series, on the other hand, is an arithmetic expression in which we add all the terms. 5 plus 8 plus 11 plus 14 plus 17 plus 20, and so on and so forth. Okay, so it is the sum of series. Sum of the terms of a sequence is a series. Okay, and we can talk about the nth sum, or the nth sum of a series, and we can introduce some terminology. I think they're going to do that a little bit later. The sigma notation. Okay, but let's say I'm dealing with the arithmetic sequence shown here. And I'm going to find the first sum. The sum of the first term is 5. Really simple. The sum of the first two terms is 5 plus 8. We'll call that S2, which is 13. The sum of the first three terms is 5 plus 8 plus 11, which is 13 plus 11, which is 24. The sum of the first four terms of the series is 5 plus 8 plus 11 plus 14, which is 24 plus 14, which is 38, and so on and so forth. So we can do that and find the first few terms pretty easily, but the question really is, how do I find, say, the 100th sum? And that's a much more difficult question to answer. Well, the answer lies in noticing a pattern. And here's the scenario I'm going to use to calculate it here. So the sum of the first 100 terms here. First, I would find what is the 100th term. And actually, I'm going to answer a simpler question. Let's just find the 10th, the sum of the first 10, right? So I'm going to find the 10th term. So what is a sub 10? Well, a sub 10 is 5 plus 10 minus 1 times the common difference, 3. 5 plus 9 times 3 is 27. 5 plus 27 is 32. Okay, so the 10th term is 32, right? And so here's what I'm going to do. And the first term is 5. So I'm going to start adding here. I'm going to do 5 plus 8 plus 11 plus 14 plus ... plus the second to last term is going to be 29 plus 32. And I'm going to list this same list in reverse order. So I'm going to write the end first, 32, plus 29, plus, etc., 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 plus, and in reverse order it's going to end with 5. You can see then that these are the same list, right? So 8. 29, the next term going down would be 26, 23, plus 23, plus ... Okay? And what I'm going to do is I'm going to add these up vertically. Okay, they're lined up in one in forward order, one in reverse order. And I want you to notice what happens when I add these. 5 plus 32 is 37. 8 plus 29 is 37. 26 plus 11 is 37. 23 plus 14 is 37. 29 plus 8 is 37. 32 plus 5 is 37. You'll notice they're all 37s, right? They're all 37s. So how many 37s are there? Well, in this case, there are 10 of them. So 10 times 37 gives me the total of this list, right? Which is 370. But remember, I added the numbers forward and backward, so every number is represented, every term is represented twice. So I have 2 times too much, right? And so my actual answer is 370, or 10 times 37 divided by 2. 370 divided by 2 is 150, and 35 is 185. Okay? Okay, this suggests a formula. All right, a formula for this here. Remember what this was. This was a sub 1, and this is a sub n. This is a sub n, and this is a sub 1. So we get these sums as a sub 1 plus a sub n. The first term and the last term added together. And then we multiply by how many there are, n, but then we divide it by 2. And there we have it. The formula for the nth sum of an arithmetic series is, and the way the curriculum presents it, is 1/2 n times a sub 1 plus a sub 2. You can do it that way. You can do, I prefer n times a sub 1 plus a sub 2 divided by 2 myself. Okay? And so there you have it. So now we can answer our question about the 100th sum. The 100th sum is simply this. We need to find the 100th term. So the 100th term, let's see, a sub 100 is the first term plus 100 minus 1 times 3, which is 99 times 3. I think of it this way, actually. 100 times 3 is 300. 305 less 3 is 302. Okay, 99 times 3 is going to be 300 less 3 plus 5. Yes, it comes to 302. So it's going to be, that the 100th term is going to be 100 times 5 plus 302 divided by 2. Okay? And I'll leave you to do the arithmetic. And that's it. That's the nth partial sum. It gets more interesting when we start talking about infinite sums, but the infinite sum of an arithmetic series is always infinite. We'll come to more interesting results when we get to geometric series.